Hey guys, so today we're gonna pick back up and talk about related rates problems, but now we're dealing with the expressions. So let's see what they have in store for us. So let's go. All right. Okay, so consider the following problem. The horizontal leg A of t of a right triangle is increasing at a rate of 8 meters per second, and the vertical leg B of t of a triangle is increasing at a rate of 7 meters per second. At a certain instant t sub 0, the horizontal leg is 13 meters while the vertical leg is 10 meters. What is the rate of change of the length c of t of the hypotenuse at that instant? Okay, so they're asking me to match each expression with the units. Okay, so here's what I know. A of t, the horizontal leg, is meters, because they tell me the horizontal leg is 13 meters. All right. So B of t, the vertical leg, is 10 meters. So that's also meters. Okay, that's good. So since we're talking about a triangle, I can make sense of why C of t would have to be measured in meters as well. All right, so I feel confident in answering one of these questions. I know that this one would have to be meters. But now they're talking about B prime. So B prime, let's see. So B prime of t of 0. Well, B prime I can rewrite as dB over dt. Right? So this was already in meters, and this is already in seconds. So it's talking about the rate of change of B based off time, and they kind of tell me that right here. It's increasing at a rate of 7 meters per second. So I know for that one, I'm going to have to opt right there. So if I'm talking about dc dt, if I was already able to explain and make sense of why C of t would be in meters, then that's kind of the same thing I'm doing here with this problem. Except I'm going to replace that with a C now. So that one will also be meters per second. And that's all there is to it. Okay, so this one, oh boy. Still another one of these problems, but now they're asking me for the radius r of t of a base of a cylinder is decreasing at a rate of 9 millimeters per hour, and the height of the cylinder is increasing at a rate of 2 millimeters per hour. At a certain instant t sub 0, the base radius is 8 millimeters and the height is 3 millimeters. What is the rate of change of the surface area of the cylinder at that instant? So, they're talking to me about the rate of change of the surface of the surface area. Okay. So I know that 9, it's a negative because it's decreasing. It's 9 millimeters per hour. And that was in relation to the radius. So that's how much the radius is changing by based off time. Which another way to say that is r prime of t sub 0 in this instance. All right. So the height is increasing at 2 millimeters per hour, which is dh dt, which will give me h prime of t. But I didn't know what the surface area was, so that's my answer choices.